Hey team, it's Mr. Z, and today we're going to add and subtract some fractions while practicing how to find the LCM. Let's try. Alright, so don't get blown away. I know I'm introducing a second variable. This is all just as an extension. If you can handle one variable, you can actually handle two. And the idea is that you want to find the LCM. So when I'm looking at this, I am looking for a number that's 7, 2, and 3 all go into. So 7, 2, and 3. I'm going to actually just multiply each of them by the missing factors. Now I'm going to do so using colors in order to help lay the seeds in the groundwork for when we make it all variables. So 2x over 7, I'm going to leave a gap, minus y over 2, leave a gap, plus x plus 1 over 3. So now, what I'm going to do is I'm going to multiply each of these that are missing the 2 by 2. Now, I do got to remember that there is a parenthesis here. This is going to create an equivalent fraction 4x. And right now, just for the sake of the discussion, I am not going to multiply it to be 14. Yes, I know it's 14, and you're going to want to do it, but I'm going to go ahead and just leave it like so. 2x plus 2 all over 3 times 2. So what we did was we created a situation where all of the fractions share a denominator of 2. Let's go ahead and add a denominator of 3 to the missing terms. So there's a 3 here already. I'm going to multiply the top and the bottom by 3. The top and the bottom by 3. This is going to result in 12x. I'm going to resist the temptation. I know normally I would multiply it out. I'm doing this on purpose. I'm trying to show you that you can do this in steps. Minus 3y all over 2 times 3 plus 2x plus 2. And I'm just going to switch the order here. That's okay. 2 times 3 is the same as 3 times 2. I hope you can identify that it's missing a denominator of 7 from the two fractions. So I'm going to multiply 7 to both parts. This first guy is going to be the same. Now all the denominators have the same parts, so I am going to multiply it now to get a denominator of 42. I'm going to multiply 7 times 3y is going to make 21y all over 42. And then I'm going to go ahead and add. I do have to distribute the 7 to both the 2x and the 2, making 14x plus 14 over 42. When subtracting, I got to make sure I include the subtraction sign with the 21y. So when I combine it as a single fraction, it is going to read 26x minus 21y plus 14 all over 42. You can go ahead and multiply each number by a factor to make it the LCM 42. I just wanted to model the process that you can do it in parts as well. So both methods are correct. If I wanted to multiply the 7 by 6, if I wanted to multiply both of them by 21, And then if I wanted to go ahead and multiply 3 by 14 to both the numerator and the denominator, that would work as well. AKA you're multiplying by the missing pieces. Do you see how 14 is really just 7 and 2? Do you notice how 21 is really just 7 and 3? And 6 is 2 and 3? That's not an accident. Remember, the idea is that you need to multiply it by the LCM, aka you want all the denominators to be the same. So it is easier to solve them numerically when they have them all. I'm going to identify that, hey, 8, 4, and 2, I can make a 4 into an 8 if I multiply both the numerator and the denominator by 2 plus x plus 2. I'm going to put a parentheses around it. How do I make a 2 into an 8? 2 times 4. And then this last guy, minus x squared over 8. I actually don't even need to change it because I'm changing the other two fractions to have a common denominator. When I distribute the 2x, it becomes 2x minus 2 over 8. This guy becomes 4x plus 8 over 8. And then I need to just make sure I distribute this negative to be here. Negative x squared over 8. When I combine it as a big fraction, it's going to be negative x squared. 2x and 4x make 6x. 8 minus 2 is 6, all over 8. Okay, now this one might take a little more finesse. So the idea is you want to figure out a number that 5, 10, and 6 all go into. I know that I can make a 5 go into a 10. Well, what does the number 6 and 10 have in common? 6, 12, 18, 24, 30. Notice how the multiples of 6 reveal that 5 6s will make it into a 30. How many? So let's go ahead and actually apply this conversion. So 2x over 5. How many 5s go into 30? 6. Plus 2x squared minus 1 in parentheses over 10. How many 10s make 30? 3. Minus parenthesis 4x plus 1 over 6. And as we discovered together, 5 6s make 30. This is going to result in 12x over 30. This next fraction is going to result into 6x squared minus 3 after I distribute the 3 to both parts over 30. I'm going to do the same, distribute to 5 to both parts. And then I'm going to remember that this negative is going to have to be distributed as well. So I'm going to go ahead and treat this as negative 20x minus 5 over 30. I always like to distribute this negative sign into my numerator and rewrite it as addition. This enables me to prevent integer errors when I combine them all together. 6x squared minus 8x, negative 5 and negative 3 make negative 8, all over 30. Now I do see both the numerator and the denominators are even, so I'm actually going to go ahead and rewrite it as 2 times 3x squared minus 4x minus 4, all over 2 times 15. That way the 2's cancel, and I'm just left with the fraction. Let's do one more. Looking at this guy, you want to identify what is the number that they all go into. 2, 3, and 21. Well, I know I can make a 3 times 7 is 21, but I know 2 does not go into 21. Well, the list of 21s, 21, and then 42. I know 42 is even. I also know that if I multiply 3 times 14, aka I multiply it by the 7 and the 2. Let me show you with factored form what that looks like. So x plus 4 over 2 minus x plus 5 over 3 plus x plus 6. And I treat 7 and 3. They have a 3 in common already. I need to make sure that all of the terms have a 2 and a 7 as well. Looking at it in factored form enables an easier conversion to a common denominator. What do I need to multiply this first bit by? X plus 4. I need to multiply it by 3 and the 7. Minus x plus 5. What is missing? Well, I'm missing a 2. I'm missing a 7. Plus, parenthesis, x plus 6, 7 times 3. What am I missing? I'm missing that 2. Factored form enables you to write a common denominator a bit easier. Now, I'm going to go ahead and multiply, not distribute, but I'm just going to multiply these numbers out in order to make it a little easier for my brain to handle. 3 times 7 is going to be 21. 2 times 3 is 6. 6 times 7 is 42. Minus x plus 5 times 14 all over 42 plus x plus 6. Now I am going to distribute this guy just because it's already alone and I don't like to dilly-dally. Usually I only like to make a couple of changes per line because this enables me to be accurate. This also kind of jump starts my brain in this next part. I'm going to have to distribute this 21 to both parts. This is going to lead to 21x. When I'm doing 21 times 4, I'm going to ask myself 20 times 4 is 80. 1 times 4 is 4. That's how I do in my head to get 84 over 42 minus, likewise, I'm going to go ahead and do 14 times x, 14 times 5. This is going to lead to 14x. To figure out what 14 times 5 is in my head, I'm going to do 10 times 5, which is 50. 4 times 5, which is 20. 50 and 40 make, or 50 and 20 make 70 over 42. And then this stays the same. I already did the work. Before I combine it, I always like to treat this negative and I have to distribute it. This is going to turn it to be 21x plus 84 over 42 plus negative 14x minus 70 over 42 plus 2x plus 12 over 42. Let's go ahead and combine my x's. 21x minus 14 is going to be 7x plus 2 is 9x. 84 minus 70 is going to be 14. 14 plus 12 is going to be 26 over 42. What a bunch of fun that was. Whew. When you're doing this stuff, I highly, highly recommend you use paper. That's it for now. Ciao.